Oh, hello.
Oh, hello, Mr. Sally.
Sorry, I had my mic off because I'm like, I'm not talking to myself. How can I help you, Eddie?
All right. I was looking at. I'm trying to get my pencil. Um, I was having a hard time doing. Where is it? I had it here. Okay, it's called the describing a set.
Okay.
And
Which? Let me go here. Which chapter 2?
yes, chapter 2, section 2.
Okay, let me go share this again. Okay, chapter 2. And about what number?
I don't recall the number right now. I wasn't. I already closed my math lab.
Okay. I'm about to that. Was it a bunch of pictures or?
No, it was talking about if you have a set with 1 through 5 and a set. I think it was like X through Z or something, and you had if uh, one would have to only apply to Y, and the other one had to apply to Z, something like that. And it was asking how many sets or how many terms there were in total.
Okay. I think that I got asked that. Let's see. No, that doesn't sound like what you're describing. Not this. Not this. And it didn't mention cardinality at all.
It did not, I don't think.
Okay. All right. I'll keep looking. There's only 25 of them. I have to get there eventually. This isn't it. Possible subcommittees. Okay, true or false. 1-to-1. No, that's not it. Let's see. This question's talking about carnality, but well, okay. I tried 24. No. Well, I'm at a loss. Okay, so describe the question to me one more time because I didn't see. I mean, I kind of saw something, but
So the question was, how many terms would there end up being if you had a set that had 1 through 5, and then you had another set that had it was like A through F, something like that.
okay.
And A would only be applied to 1, and you have to figure out how many sets or how many terms are in total with that. And then the part B was how many sets would there be if A was paired with 1 and B was paired with 3. I'm trying to see if I can find it too.
Yeah, because if you can find, well, I guess if you can if you can write it down, or I can give you this, let you share screens, I guess.
I'm going to Alabama, and he realizes Gary Stewart, great job of being outside, maybe cut back. Exactly what Harris.
So we have set A, 2, 3, 4, and 5 in it. Set B had a
Kansas City back on lead at 17-14.
B, C, D. How many letters were in the second set?
It was A through F, so 5 letters.
A. Okay. Okay. And so we're partnering up. But everybody else can partner up with everyone else.
Right. I
Okay. Well, so if it's A just has 1, B could go with 1. I have to clarify. Partner B with 1 or just A1 is just an example.
I don't remember.
Let's see if I can. It's designed to be random. Alright, we got more.
This is F6X. Not much has changed, except
Yeah, I guess I'd have to see the question in order to know quite.
Right, I was. Because I'm going to continue to try to look for it.
And Siri is more helpful than ever. Hey Siri,
You said it was in your Chapter 2 test, right?
Yeah, the chapter review exam.
Yeah.
Okay, so I have it here.
nice.
It says that
Actually,
Not. Stop. Okay. So on your test, which one is it?
on my test is question 3.
Okay.
Can you hear me? He's actually
Okay. I got it now. Alright, I'm gonna take a picture of this so I can share it with the screen. Alright, let me get off. Let me go back to sharing my screen again.
At 20-yard line, down 3.
That was your question?
Yeah, for number 3?
Yep.
I don't see it on the screen.
Oh. Okay, how about that?
Nothing yet.
Nothing yet?
Nope.
I see it.
She sees it.
I don't see it.
Not anymore. It's
Not
really
anymore?
small.
How about now? Does everybody see it now?
No.
No, not yet.
Nothing?
I see it.
I'm able to see it as well.
Okay. I think it's because we got too many sets going on here. I'm gonna mute somebody. Maybe nobody yet. Okay, let me go back to here. Okay. Can we see it now?
No.
No, not yet. But if it's a question from my exam, I'm looking at it right now.
You're looking at it. Okay. Figure out why it's not showing everybody else's screen.
What it could be the problem is that when sound comes on, it shows the other person's screen, so the person with a lot of sound in the background, like the TV, it's showing their page. So
Right.
what you
Right.
can do is you can click Peter's name and it's reading his screen versus someone else's screen.
Okay. So I'm going to be complete jerk, and I'm going to mute everybody but Eddie. And that should just mean that you guys can. Oh wait. I don't want to. I don't want to mute you, Eddie. I want to keep you mute. Okay. All right. So that means everybody should just be able to see me now, and when Eddie talks. Okay. Can you see it now, Eddie?
No, I still don't see it, but like I said, I have it on my test page.
Okay. All right. Well, I'm going to cross my fingers and hope this works. Otherwise, I'm being a complete jerk and no one can see anything for a couple minutes. Okay. So determine how many one-to-one correspondences are possible between the two sets given the following condition. So question A, if in each correspondence P must match with 1. So that means when I partner these things up, I can only have P with 1, but then everybody else gets everybody else. So like Y goes with 2, and Y can go with 3, and Y can go with 4. So I could have that combination.
Okay.
And then I can just go through each of the other letters. So Z could go with 1, Z could go with 2, Z could go with 3. And so if I partner them all up, knowing that P is just going to be limited to the 1, Y can have 5 partners, Z can have 5 partners, W can have 5 partners. So am I making any sense here? That
Okay, so you're saying that P would only hook up to 1, but 1 could hook up to the other 4 letters?
right.
Okay.
So I can have 5 sets that have Y's in them, and then I can have 5 sets that have Z's in them. So like Z, what am I? Z4 and Z5. Okay. So if P has 1 option, Y has 5, Z has 5. Let's see. So that puts me what 20. And where am I missing the other 3? I gotta think this through here. If P must match with 1. So there are.
Maybe 24.
No, it should be 24. I'm trying to think where the other ones are coming from. All right, so here's 5. There's 5, 10, 15, 20. Let me try this the other way. There's 1. Okay, the fact that P1 has to be in there means there's 1 less combination. Oh, 1-to-1. Oh. Okay, never mind. Hold on. Scratch this thought process for a second. Sorry. Okay. So it's a 1-to-1 correspondence, which means if P's partnered with 1, then Y could be partnered with 2, because it's a 1-to-1. So 1's already got a partner, but the other guys I don't know what they could be. So it could be Y2, Z3, W4, and V5. 5. Okay, but that's just one way to do it. So if I do P1 again, and if I partner Y up with somebody else, so say it's Y goes with 3 now, and Z goes with 2, and then W stays with 4, and V and 5 go. Does that make sense?
Yeah.
Okay, so I have 2 down of the possibilities, but if you kind of think about it, what's going to happen, like here I'm just switching 2 like Y2, now it's Z2, the next one will be W2, the next one will be V2.
Right.
So there's 4 sets just with moving the 2 around. Forgot how to show that. Okay, so let's see. Here I want 2 to go here, and then I'll put 3 and then 4 there. And then I'll do that again. Alright, so then I want 2 to be at the end. Okay, so then that's that set, but I can do this even more. I can, well, let me go back up to the original. Okay, so let's say I want to put 3. Let's see. So we already put 3 first. So let's say I want to put 3 down here. Then I'll put 4 here. And then 5 would go here. Sorry, 5 here. And 2 here. Okay, so that's a different correspondence than I have from the previous ones.
Right.
Right? And so that's what you're keeping track of with all these things, is how many different possibilities are there. So that first one's a pain in the butt because you have to list out all, hopefully recognize a pattern so you don't have to write all 24 combinations down. But
Okay.
that's what it's asking for you to do. So like part B, it's got more restrictions. Let's steal this and go down. Let me go down here. Okay, so with B, they told us that P goes with 1 and Y goes with 5. So that just leaves Z, W, and V to randomly associate. So I'll go Z2, W3, and V4. So now these first 2 are locked in, so I just get to play with these 3 combinations.
I think I see how this is going.
You see how that works? Like it's a pain in the butt because you're having to rewrite and sort of come up with all the different possibilities, but that's what it's asking for you to do. That work?
Yeah, that works for me.
Okay. You want me to keep going with that one, or are you happy with that?
No. I think I'm good with that one.
Okay.
Question.
Oh, how'd you get your mic back on? Did you override me, Gabby? Good for you.
I just, on that problem, are we going to have questions like that one specifically on the test?
That is a fabulous question. I can't recall right now. I think I went through. Oh, let me get off this. Are you guys seeing this like mirror image, which is going on forever?
Yes.
All right, that's annoying. Okay, so I'm gonna look and just double check. I think this is a little on the long side, and I know I was looking at it this morning. I don't recall this specific question.
Do I?
Six out for about 3.
Okay.
So you go twice a year.
I have a question.
Yes. Uh-oh. You quieted down on me there. I assume it's not David. You have to unmute your mic. Let me stop the screen share there. Okay. Okay. All right. I think you can talk now.
Okay. On the first one that we did, I honestly didn't completely understand that 100%. Would it have been the same if the way you started it the first time that you erased it, if we continued it in 4 sets and just added the P1? Would that have been the 24?
Right, right. It's with that very first part, they told us that P has to go with 1. So the other letters and the other numbers, I'm sort of writing down how many different combinations I could generate with that. But all I know with that first condition is that P goes with 1, so the other letter can go with 2 and with 3 and with 4. So I'm just counting how many different combinations I could come up with when I set that up.
Okay. Does anybody else have a question? If not, I have one.
You can go.
Okay. On the exam 1 review,
Okay?
there was a problem that was 6 plus 12 plus 18 plus 600. And apparently, I guess we had to figure out what the answer was. The thing told me the correct was 30,300.
Okay?
But I tried working it similar to the other ones with that, what is it called? That Gus method or something like that?
The Gaussian method.
Yeah,
Okay?
the Gaussian method. And it didn't quite work. Like, so what I did was that the 600, I added it to the 6, and that gave me 606.
Right.
And then I divided that by 6 because the difference was between 6 and 12 was 6. So that gave me 101. But then when it came to multiplying, I did the 606 as I would in the other problems, and the
Right.
answer it gave me was something completely different.
Okay,
So when
let me pull up your question. I don't think your name is David.
No, Tanya.
Tanya. Okay, so let me go pull up your. Tanya is somewhere in this list. Tanya, what's your last name?
Palomares. Palomares.
Okay, thank you. I knew that. Okay, it's chapter 1, right?
Yes.
Okay, and what number in chapter 1?
I'm not sure. Maybe like problem 4 or 5, somewhere there.
Okay.
It starts with 6 plus 12.
6 plus 12. Okay, okay, I got it.
Okay.
I gotcha. All right, let me pull that up over here.
Game day. Best day of the week. And when you play one week fantasy football on DraftKings, every week.
And I'm going to go back to sharing my screen.
Knowledge and expertise and skills.
And, okay, so let me do that.
I've actually left them both at the same time. And this week, you get it just.
Okay. All right, can you see your question up? Maybe, hopefully. I know somebody can. Okay, so to do this one, I actually need to know how many terms are in the pattern before I can use the Gauss's trick. So let me pull up this. So one of the few formulas we need to make sure we have in our heads is the sum of a general term for an arithmetic sequence, which is the first term plus n minus 1 times the common difference. So in this case, 6 plus 12 plus 18, I want to know how many numbers out did it take before they got to 600. So 600 equals the first number, which happened to have been 6, plus n minus 1. I don't know. I'm solving for n. And looking at the pattern, it looks like you're adding 6 each time. So the common difference in that case would be 6. So I'm going to solve for n first. So 600 minus 6 is 594 equals n minus 1 times 6. And then I'm going to divide by 6. So I'm just going to pull out a calculator, which gives me 99. Okay, so then add 1 to both sides. I get the that there were 100 numbers in that pattern. Okay? So when I use Gauss's trick, we're at 6 plus 12 plus 18 plus ... plus 600. So I'm going to add that twice. So 600 plus 594, I'm sorry, 594, plus 588 plus ... all the way up to 6. When I add those two rows together, I should get 606 plus 606 plus 606. You know, there's a whole bunch of 606s, right? How many 606s are there? There are 100 of them. So the sum formula then would be there's 100 times 606, but if you remember, I added that whole row twice, so that's twice as big as I want it to be, and that should give us the 30,300, which it does. Okay. Sorry, I can see you talking. I don't hear you.
There's a red button on me.
Oh, okay.
Can you hear me?
Yes, I can hear you now.
Okay. I haven't been working the rest like that, and I got them right. Does it work different when it's adding by a lot more numbers?
There, I'd have to see what you did with the other cases, because in this section there's arithmetic sequences and there's geometric sequences. So I'd have to see what you did originally to tell you if it was right or not. You might have done it the way I showed you and you just didn't know it, or typically with these arithmetic sequence ones, you have to solve for n first and then do Gauss's trick.
Okay. Thank you.
Uh-huh. Who is next?
Okay, I have a question. Can you hear me?
I can. Yes.
Okay.
Go ahead.
On the recursively defined sequence, I remember I had asked a question through an email, but I was trying to just like get another example of it so I can make sure I got it right.
Was it which practice test is practice test 1?
I don't remember, but I know it's in my notes. So I know it's in
somewhere in your note.
One,
Okay.
two.
22?
No, it's in like 1, 2.
1, 2. Okay.
Section 1, 2. And the problem looks like, let's see, like this.
Oh, sorry. Go ahead.
Can you see it?
I can. Oh, from my notes.
Yes.
Okay.
I was just wondering if I can get another example of that.
Oh,
so
sure.
I can make sure I can fully understand that.
Yeah. It's that one is more about just recognizing what the word recursive means.
Okay.
But yeah, I can. Well, here I can just make up a recursive one.
Okay.
Okay. Let me do the screen share. And I'm going to ask you guys before you jump off, is this even useful to send this video out? Like I did it yesterday, and I had a few people go, "Yeah, it was great," and I watched it, and I'm like, you can't see half of what I'm doing. I don't know if it's even worth it to send the whole class this video.
Yeah, yesterday I was looking, and some of the problems I couldn't see, so.
I just can't imagine anyone would go, "Oh, this is exciting." I'd just pop a bowl of popcorn, but oh well. So if you guys don't think this is going to help anyone, then I won't share it. I'll just keep it. We'll keep it to ourselves.
It might, but I don't know. I wasn't able to see a lot.
It works if you could see it, and the reason I wasn't seeing it, I figured out was because I clicked on somebody else's picture, So I had to go back and click it on your picture to see what you were pulling up.
I don't know. I'm trying Google Hangouts with Air to see if I like it. I might try something for the next test to see if it's a little bit better software. I mean, the fact that if anyone talks, it like steals the screen from everybody. I'm not a big fan of that. So, but this will work for now, I guess. Okay, so the request was to look at recursive sequences again.
Yes.
So let me just. I'm going to tell you that the recursive numbers. The first number is 5. And the second number is 9, and I'm just making this up, so in case you're going, where's he getting this from? I'm making it up.
Okay.
Okay, so then I'm going to tell you that the nth number is n plus 1 times, I take that back, is going to be a sub n minus 1 minus a sub n minus 2. Okay, and we're going to write out the first 5 numbers of this pattern. Okay?
Okay.
All right, so the first number is 5, the second number is 9, and the third number, okay, so the third number in our pattern is going to be 3 minus 1 minus, oops, screwed up an A there, 3 minus 2. Okay, so what that means, 3 minus 1 is 2, so it's the second number minus, did that again, the first number. Okay, so the third number in our pattern, I'm going to go back to the second number. The second number was 9, and the first number was 5. So the third number in our pattern is going to be 4. And then I go on. So I'm going to go to the fourth number. So the fourth number, I'm just going to copy and paste this a little bit, but I'm going to modify it. Actually, I lied. I'm going to copy and paste this. So I'm going to put a 4 in where that n goes. Okay, and then I'm just going to translate that. So that would be 4 minus 1 is the third number minus the second number. Okay, so the third number was 4, and the second number was 9. Okay? So that puts that at negative 5. Okay, but hopefully at this point we can see that to get the next number, I just go the previous 2 and subtract.
Yeah.
So the fifth number would be negative 5 minus 4 would give me a number, but anyways, does that sort of help you see it?
Yes. Yeah, that was a lot better.
Okay.
Thank you.
Uh-huh. Who is next? Yes, I can see you have a question, but I just see the lips moving. You must turn your mic on. That's okay, still not on. If I can, I don't know if I can hijack you from here. Nope, I can't turn it on. Okay, there you go. You had it on a second ago. That's on.
Is it on?
It's on. It's on a second ago. Do you know sign language? No. I'm feeling bad for it. Okay. Yeah, I'm gonna turn Gabby off because I can't hear. Okay.
Can you hear me?
Yes.
Okay. Sorry. Are you gonna be available for like conference tomorrow?
What time?
I don't know. Whatever time. I can go after the other ones are done with the exam because I'm taking it at Central at 10 a.m. on Saturday.
I'm afraid to answer that question. So I'm at North Campus.
Uh-huh.
Oh, that's not going to discourage you. Okay. They're taking their test about noonish. So I will be, Gabby, don't smile. So I will be in my office in the morning, sometime after 9 o'clock. So anytime between 9 and 12, I will probably eat at some point. But yes, you may go to my office and I will be there.
Okay, well, I pick up my daughter from school at 10:30, so how about 11 and I'll be there sharp, like at 11.
Okay, and you can bring your daughter. That's fine.
Oh, sorry, I didn't ask. Yeah, because I went for tutoring today and these guys had no clue about this stuff.
That's because they're not that good. I'm kidding. I shouldn't say that. I'm so sorry. That's not very professional. Yes, that's fine. 11 o'clock sounds fabulous.
Okay. Sorry.
No, you're fine. Technically, anyone can show up anytime I'm in my office, so I probably won't be announcing that for fear that 50 people will knock on my door.
Right.
But Eddie, you can come.
Okay.
Gabby's having too much fun with this.
I had another question before we take off.
Okay.
It was the cardinal set.
Oh, good. Carnality. I like that. Okay. Test 2. What number?
Number 6.
Number 6. Okay.
Here you go, baby.
I will. You can call me whatever you want, I guess.
My daughter, sorry.
That's okay. Mine are in bed, so good for you. All right. Let me pull yours up, Eddie, and then I will. I'll pull it on the screen. Alright, number 6. Here we go. Find the cardinal number for each of the following sets. Okay, let me take a picture of that so I can stick it on something I can type on.
Yeah, I think I got the gist of it. It's just sometimes it seems like it's like if it says like 1 through 10, it's 10, but other times it'll say 1 through 11 and it'd be 12.
Okay. You want A, B, C, D, or just?
Well, see, like B, when I answered it, I would have thought it was 500, but it's 501 because you had to add the first term.
Okay, well, I'll give you a hint. On B and A, they're both arithmetic sequences. So that nth term formula that I just keep pulling out of thin air is going to help save the day on something like this. Like half this test is just pull out the arithmetic formula. Okay, so if I ended at 1006 and my first number was 6, common difference would be 2. I'm just solving for n. So subtract off the 6. N minus 1. Okay, divide by 2, so you get 500. And then if I add 1 to both sides, I get 501.
Okay.
So anytime it's arithmetic, you can use this approach to generate how many terms are in the set, and that's the cardinality of the set, is the number of terms there.
Would it be the same for number C?
C is not. Let's see. C is 1, 2, 3, all the way to 88. So they kind of. I mean, if you look at the answer and you look at the question, they're telling you that the numbers in the set are really 1 squared, 2 squared, 3 squared, but there are 88 of those numbers. They told you that it started at 1 and ended at 88. So it's kind of like a trick question.
Okay, so how is that one 88, but A is 79 when there's 78 terms?
It goes back. Let's see. Let me set that up. 94
Go back to the standard signal, third down.
plus n minus 1 times 1.
That's 9 third down conversions.
So we just want 94 minus 16. That's 78 with n minus 1. So there are 79 terms. Okay, so part of the problem is, well, not part of the problem, but in C, if I can get that on the screen, in C they're starting at the number 1. So they literally went 88 numbers away from 1. But in A, we're starting at 16. So we have to treat the 6, so I'm sort of subtracting 16, figure out what the first number was.
Okay.
Anyway, so I would say if you recognize that it's an arithmetic sequence, go ahead and use the general term formula.
Okay.
One thing, if it makes you feel any better, I put a note, and I hope I was clear, so you guys can correct me on this. But I told everyone that you're going to write out on a piece of paper how you're getting the answer.
Yes.
And that you're going to turn that in to me when you get up to go away. And then when I go back to your test, if you made a little silly error like, I put 78 because that's what I thought it was, and it should be 79, I think you still deserve most of the points, even though the computer's not going to give you anything for it.
Okay.
So I hope I was clear in my directions at the start of the week about what you're turning in.
Yeah. Well, for me it was.
Okay, well good. Anyways,
What kind of calculator can I bring?
Because this first test has got a lot of summation on it, and you're dealing with some pretty unpleasant numbers, like 1,006. Okay, fine. I'm gonna any calculator's fine.
Okay.
But in future units, like I was just looking at Unit 3, and Unit 3, I'm showing you how to estimate fractions and decimals. I don't think a calculator is appropriate at that point.
Okay.
So just FYI. So for this test, any calculator's fine, but in future, I'm going to have a hard time justifying a calculator.
Okay. And then for formulas, besides the arithmetic formula, what other one will be used a lot? So I can get that on the top of my head.
Geometric one came up a couple of times. The nth term for geometric is... Sorry. Be consistent about how I'm labeling this. Is the first term times the common ratio raised to the n minus 1 power.
Okay.
And that does the exact same thing that the arithmetic one does, but it's for geometric sequences. So if your pattern is you're multiplying by a constant to get to the next term. Anyway, so those two formulas, aside from all the vocabulary, and I am just going to suggest that you look up magic squares. I cannot tell you why the textbook happens to get real excited about that, but just make sure you know how to set up a magic square.
Okay.
And you said the ratio for the geometric is what again?
Well, let me generate a pattern here. And all right, so let's take something like 2, 8, 8, 32, 124, I think is the next number. I think I'm doing that right. Anyways, so what am I doing to get the next number? I'm multiplying everything by 4. So to see that, I can take any two numbers in the sequence and set the later one divided by the previous one. I should get the same constant.
Okay.
So if I do 8 over 2 or 32 over 8 or 124 over 32, they all should equal 4, which is that common ratio.
Okay.
Okay?
Got it.
Anywho, so on that note, I have to run to another meeting. So yay! But like I said, I'll be in my office tomorrow. Oh, hi, Crystal. Sorry you jumped in right at the end. Yeah, I can tell who everyone is. Oh wait, I also have Luisa. And the mysterious Gustavo. So I'll be in my office tomorrow morning at North Campus. If anyone has any specific questions, so I imagine I'll be very popular about 11 o'clock for a 12 o'clock test. You can stop nodding now. You don't have to. I've got a very tiny office. I don't know how I'm going to do this. So, anyways, any last second questions or just you? I believe in you. Good luck.
Okay, I have a question.
Okay.
It's asking, on one of the examples, it's asking us to make it into a cubic form. It's on test 1.
Test 1. What number?
Question 8 on mine.
Okay. We're not sharing. Okay. Who's speaking? What is the last name of the student speaking?
Oh, Cabrera. I'm sorry, Leslie Cabrera.
Cabrera. Okay. And you said it's number 8?
Uh-huh.
On the one you're currently looking at, or a previous one?
Current.
Okay. I'm gonna, because I can pull that up. All right, the pattern 1, 8, 27, 64, 125. That one?
Mm-hmm.
Okay. Let me take a quick picture of that. Okay, that did not work. Let me try that again. All right, bear with me. Okay. And here we go. The screen share. All right. So this lovely question here. Just asking about the first part or any part or?
I don't know how to do it. I've tried numerous times on the repeat and I just don't.
Okay. Well, let's see. For starters, let's see. So I would say cubics get pretty big pretty fast. So I guess my question is, do you know even what they mean by cubic? So they're doing 1 cubed. Okay, so we got 1 cubed is the first number. 2 cubed is, sorry, cube, not to the squared, is the second number, and then 3 cubed. So that's how they're getting this. So I would just say let's generate out the first couple. So 1, 8, 27, 64, 125, Be 5 cubed. 6 cubed is, I think, 243. Is that right? 216. Okay, so 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is right at 1,000. And 11 cubed is 1331. Okay. So part A, what's the least 4-digit number greater than 1,000? So when I did 11 cubed, that's the first time I crossed 1,000. The biggest 3-digit number in the pattern happened to have been 729. What's the greatest number in this pattern? Less than 10 to the 4th. So, 10 to the 4th is 10,000. So I'm just going to guess, just a random number to start off with. I'm going to look at, say, 14 cubed. And 14 cubed is 2,744. So it's not big enough. So let me try 16 cubed. Now you play that high-low game. I'm just I'm guessing numbers until I find something that satisfies what it's asking. So 16 cubed is 4,096. Let's go with 21 cubed. Let's try that. All right, 21 cubed is 9,261. Now I know that's the answer because it says that, but I would then go, hey, wait, I'm really close. Let me try 22 cubed and see if it goes over. And I get 10,648. Hey, I went over. So clearly 21 cubed was the best choice. So therefore, it's 9,261. Right.
Okay, I understand now. Because at first I didn't really understand what it was talking about. I thought I was supposed to cube, like get the numbers and have it cubed. So what I was doing, I did 3 cube itself and all that other whatnot.
Right.
I was typing it in, and that's why I was getting it wrong. But this, okay, I get it. This is perfect.
Okay. Okay. Well, on that note, I will tell everyone to go to sleep. Y'all are up way too late. You're more than welcome. If you have any last-second questions, like if you're going to test on Saturday, although testing Friday is even cooler, a smaller crowd on Friday. So, and I'll be up in my office, so that's even better. Anyway, so if you have any questions for those that are testing Saturday, you can email them to me, and I'll try to get to them. So, all right. On that note, I'm going to end this adventure. And is this worth sending out on YouTube, or I don't know? I don't know.
Yeah, I'd say so.
Eddie says yes. Crystal's like, no, probably not.
I only got like the last 2 minutes, so for me it's a negative.
Yeah.
Well, right, but if other students would like to watch your questions, I don't know. I'll look at it, and if I actually see stuff, then yeah. All right. Well, have a good night and good luck.
Thank you.
And I'll see you soon.
Thank you.
You're welcome.